Good morning, everybody. In the previous video clip, I have just explained you about the value of the polynomial and the zeros of the polynomial. I hope you have understood the concept. Now, today I am going to start the topic remainder theorem. Now, try to understand what the remainder theorem is. That actually this topic is very easy. If you are going to listen it carefully, you will be able to understand it very easily. Okay, now see. Let fx be a polynomial of degree n is greater than 1 or equal to 1. Means if the polynomial is there, it should be degree of 1 or greater than 1. Means either it should be, we can say the linear polynomial, quadratic, cubic or biquadratic, whatever. Means the degree should be 1 or more than 1. Okay. And let a be any real number, and if a be the any of the real number, any number, and when fx is going to divided by x minus 1, then how you can find the remainder? That the remainder theorem says. Suppose if I am going to take here x square minus 4x plus 5. So this is, we can say this is a kind of a polynomial, and you can see since here degree is how much? Degree is how much? Maximum power is 2. Degree is how much? 2. So if this is a kind of a polynomial, degree more than 1. Now we can take any real number. Suppose I have taken here 2 a real number. So here x minus a. If I write here x minus a, this number I have taken as an a. Now if this polynomial is going to divided by this polynomial, suppose here written x square minus 4x plus 5 is going to be divided by x minus 2, then what after dividing you will get here question and you will get here remainder. So what the remainder you are going to tell, this only the thing is going to be explained by the remainder theorem. Okay, now few important thing you should know about the remainder theorem is that how we are going to find the remainder. See here. So first of all, what we have to do, whatever the divisor is there, means x minus a is here divisor, because we have to divide this polynomial fx by x minus a. So equate the divisor with the 0, find out the value of the a and put the value of that x, find the value of the x, and whatever the value of the x is there, put the value of the x in the given polynomial. So after solving, whatever the number you will get, that will be only the remainder. See here. And some important thing, degree of the remainder should be always less than the degree of the divisor. You know, see here, the degree of the divisor is how much? 1. So it means we can say the degree of the remainder is less than 1. So less than 1 means what? 0. And if the degree is 0 means it is simply a constant. So we can see the degree of remainder is 0. Therefore, the remainder will be a constant number. So whatever the things I have just told you right now, I will just explain all the things with the help of one example. Try to understand. See here. Find the remainder when the polynomial fx x cube minus 3x square plus 4x plus 50 is divided by x minus 3. So if I wanted to find what will be the remainder if this polynomial is going to divided by this one. So if you are not knowing the remainder theorem, so from the concept of the class 8, you will go for the long division method. So we know that, see here I have written x cube minus 3x square plus 4x plus 50, and her divisor is x plus 3. So how to divide, I hope you know, but once again I'm going to explain. So for dividing by the long division method, we have to always go for the first term by first term. So x cube by x, so x cube by x, x cancel how many times? 2 times, x square. So I've written here x square. Now x square has to be multiplied by x plus 3. So x square into x cube, and x square into 3. To 3x square. We know that during this process we have to change the sign of the bottom, whatever the terms are there. So here x cube is there, so here minus I have written, 3x square is there, so minus 3, minus written here. So plus x cube minus x cube cancel, minus 3x square, adding we have got here minus 6x square, and the rest I have written as it is, 4x plus 50. Now again first term by first term is here minus 6x square minus x square, and here x. Now x is going to be cancelled by the one time, so minus 6 is there, so I have written here minus 6. Now minus 6 multiply with the x, we have got here minus 6x square. Now minus 6x is going to multiply with the 3, so 6 3 is minus 18x. Again we have to change the sign, both are the negative, so we have done plus here. So these are going to cancel out. Now 4x and here 18x. After adding we have got here 22x and here 50 as it is. Now again we are going to do the first term by first term. So 12x by here x is cancelled, only 22 is written. So 22 I've written here, so 22 into x, so 22x and 22 into 3, so 66. Again change the sign, this has cancelled and this has remainder minus 16. So we can say when this polynomial is going to be divided by x plus 3, we have got here remainder minus 16. So this is, we have solved by here the long-term division method. Okay, now what the thing is, you can see, I told you the degree of the remainder is less than the degree of the divisor. So here divisor degree is 1 and here you can see 0 because here no variable is obtained. And also I told you that remainder will be always a constant. You can see minus 16 is a constant number. So these the things are there. But if you wanted to find the remainder by the help of the remainder theorem, so what we can do, try to understand. So if you wanted to solve the same question by the remainder theorem, so what we have to do, I've written here from remainder theorem, the fx is given here, the same thing. Now, whatever the divisor is there, I have just assumed as gx. You can assume some other thing also like px, dx, whatever you wanted to write. So I've written here gx. So gx is equals to x plus 3. Now what we have to do? We have to equate gx with the 0. So I've equated the gx with the 0. Always we have to do the same thing. Means whatever the divisor is there, equate the divisor with the 0. So gx equal to 0 means x plus 3 equal to 0 and find the value for x. The x value is here minus 3. So once again I'm going to tell you, so if you wanted to use the remainder theorem, equate the divisor with the 0, find the value of the x, and whatever the value of the x you have just got, just put the value of that x in the